Hi, and welcome back. So let's do another Calc 1 final review problem. So let's try to find, let me move this off the screen too. Let's try to find the limit, so the limit as x approaches 0 of the sine of 5x divided by, there it goes, divided by the sine of 3x. Okay, so this is the problem, so if you want to pause the video here, and now I'm going to just work through solving this. So if you remember, what's our special limit that we're going to use to evaluate this problem? Well, it's going to be, and you can see whenever you see the limit as whatever our variable is approaches 0 of the sine of something with that variable in it, whenever you see that inside of a limit, you should always immediately just remind yourself of this special limit, that the limit as x approaches 0, or as actually, you know what, I'll write this differently. I'll write this, the limit as h approaches 0, just because we could have any variable in here. It doesn't have to be an x. The limit as h approaches 0 of the sine of h over h, that's always going to be equal to 1. Right? So this is our special limit case. And we could even say, and we've talked about this in past videos, that we could even say that, you know, maybe h is equal to, well, let's say h would be equal to 5x. So therefore, it would be the same thing as saying the limit as 5x approaches 0 of the sine of 5x divided by 5x. So that's going to also be equal to 1, right? And even we could say, you know, as 5x approaches 0, the limit of just plain, I'll get my eraser out, the limit as just plain x approaches 0, that's also going to be true, right? So this is essentially going to be the rules that we're looking at for solving this problem. And the other thing that, and remember the big thing, the most important tool that you should have in your toolbox when you solve problems like this is multiplying by 1, multiplying by some fraction that works out to multiplying by 1. So what can we do to start off with? Well, the first thing I do is, and we can actually maybe combine these into, this is a good color, I think. We can actually combine a couple of steps here, and partially because this is a final review and I think I might have gone through this problem. So the first thing I'm going to do is I'm going to write this as, so we know that the limit of a quotient is equal to the quotient of two limits, right? So I can move this limit expression into my fraction, right? And I'll rewrite this as the limit as x approaches 0, and I'm going to leave some space here, of the sine of 5x, all of that over the limit as x approaches 0 of the sine of 3x. Sine of 3x. So hopefully you can see, and I know I wrote that, I gave myself a lot of space in here. Maybe you can see what I'm about to do, but all I did was I just distributed, or I just put this limit into my fraction, and I put it in on the top and then also the bottom. And so now, what can I do? Well, I'm going to be able to multiply. First off, I can multiply my entire fraction here by 1. And how am I going to multiply this by 1? Well, the best thing to do is to multiply this by 1 over x times 1 over x. So if I do that, and I just wrote this down for a second, actually, you know, it's good for me to write this down for just a second, but if I do that, what does it make? What if I multiply this 1 over x times 1 over x divided by 1 over x into this bigger fraction? what does this start to look like? Well, it starts to look like the limit as x approaches 0 of the sine of 5x divided by x, right? Because I multiplied this 1 over x into my numerator, so sine of 5x divided by x, and then all of that divided by the limit as x approaches 0 of the sine of 3x, and once again I'm multiplying by 1 over x, or I guess I could say in here I'm dividing by 1 over x, so I can multiply this 1 over x into my denominator. And when I do that, that's the same thing as doing the sine of 3x divided by x. So hopefully that made sense. If that didn't make sense, I think I did a video earlier on in the playlist where I did that maybe a bit more slowly and explained it a bit more while I was doing that, but hopefully that made sense. So anyway, the important thing to realize is that now we've got something that looks a whole lot like our special limit case, and it looks even more like this other special limit case where we can say that the limit as x approaches 0 of some coefficient times x divided by that same coefficient times x is going to be equal to 1. So now what's the only difference in both of these cases, in both our numerator and our denominator? Well, the only difference is we don't have the right coefficient in front of our x term, right? So now what are we going to do? Well, what we're going to do is we're going to multiply both our numerator and our denominator by 1, but the way we're going to do that is we're going to multiply it times this coefficient, this 5 over 5. So we multiply this numerator times 5 over 5. And then what do you think we multiply the denominator by? Well, we multiply it by 3 over 3, right? So now, after we do all that, let me actually choose some more colors. I've got some, this color is called bubble gum. I'm going to switch to that. Maybe this will look nice. So then, after we do that, so after we multiply through by this, what does our fraction start to look like? And all I'm going to do is I'm going to multiply this 5 over 5 into this expression right here on the top. So we get the limit as x approaches 0 of 5 times, so I just multiplied this 5 into our expression, and I'm just going to write it first. So it's 5 times the sine of 5x divided, and now I'm just going to move this 5 into the expression again. So I'm going to write this as 5x. So 5 times the sine of 5x divided by 5x, and then the same thing happens in my denominator, right? So I'm left with the limit as x approaches 0 of the sine of 3x, and I'm going to multiply this 3 out, so I'm going to have 3 times the sine of 3x, and all of that divided, I'm going to multiply this 3 times that x, all of that divided by 3x. So now, what's the last step? And maybe you've seen this in the past video. Because we're just multiplying by constants, didn't mean to do that. Let's see if I can, there we go. Because we're just multiplying by constants here and also here, we can move those constants out in front of our limits, right? We can move these constants because the constants aren't going to change when we take the limit, right? So actually, I'm going to give myself a little bit more space. There we go. I'm kind of using a new program right now, and it's working nice so far. So anyway, we move our constants out in front of this limit, so our expression is now 5 times the limit as x approaches 0 of the sine of 5x divided by 5x, and all of that over 3 times the limit as x approaches 0 of the sine of 3x. So sine of 3x divided by 3x. And now, hopefully you can see, if you remember when we were talking about this property in the beginning of the video, we've got the same coefficient, and because as 5x goes to 0, x is also going to go to 0, we're able to say that as x goes to 0, even though we have a 5x here instead of just a 1x there, because this coefficient is the same, the limit is going to be the same. We're still going to get 1. So therefore, we are now at the point where we can actually take these limits. So we know, because of our special limit, and let me get there, that's a good color. So we know, because of our special limit case, where the limit as x approaches 0 of the sine of some coefficient in front of x over that same coefficient in front of x, when we take that limit, this is going to be equal to 1. And then down here, the same thing happens. The limit as x approaches 0 of the sine of 3x over 3x, this is also going to be equal to 1. So it's this much of the expression that we just took the limit of. So now, what are we finally left with? We're left with 5 divided by 3, and we could just say we have times 1 divided by 1, which we know is just 1, so our final answer is going to be 5/3. So anyway, that's our final answer. Hopefully you found this at least somewhat useful, and if you keep watching, I'm just going to keep doing final review problems. Thanks for watching, and I'll see you soon.